starting this batch of rapid fire, we have problem 6 from the 2025 10B. The line this divides the square region defined by x between 0 and 2 and y between 0 and 2 into an upper region and a lower region. You should probably pause here at this dot and go ahead and create what it is they said so you can think about that thing. So we'll go here, we will draw a square approximately, and this will be 1 and 2 and 1 and 2, and we're going to have a y-intercept of 1, and we're going to go up 1 and over 3. So we're going to end up over here and like that. And so if I'm going up 1, see, as you draw these things, you want to reason as you go. Rather than keep reading here, we have more information that we can generate at this time. So this is the point, of course, 3, 2, if you wanted that. I kind of want to know what this point is. So how am I going to get that? Well, it's a matter of slope. You're just going to say, well, number one, you can take the 2 and plug it into the x right now, because that's the x coordinate everywhere on that vertical line. So it's 2/3 plus 1 is 5/3. And so this will be 5/3, and this part right here will be 1/3. 1/3. Okay, good. All right. Well, what do we do next? I think that's all the information that you can gather. We've reached what I would call, when you know this is 5/3, we've reached a significant conclusion in the problem. And when you do that, now is when you go back and keep reading and you set the conclusion aside until you're ready to act on it. So the line x equals a, which is a vertical line as we just discussed, divides the lower region into 2 regions of equal area. By the way, we're kind of doing coordinate geo here. I wonder if that's a precursor to things to come in this contest. We'll have to wait and see. The line x equals a divides the lower region into 2 regions of equal area. Pause, let's find another significant conclusion. How can I find the equal area if I don't know the area? Okay, so we're going to find the area really quick. This is going to be 1. What do we have? A trapezoid. You've got 2 parallel bases. So it's the average of the bases. 1 plus 5/3 is 8/3 over 2, which is going to be 4/3. That's the average of your bases times your height. Probably would have been better to write 8/3 divided by 2 times 2 and just cancel the 2's. That's where we're going to end up at in the end. So the average of the bases is the sum of them over 2, but then you're multiplying by 2 because that's your height. Your height is running horizontal parallel to the whiteboard. Yeah. So then what now? We have 8/3 as the total area, and we're going to go right back and cut it in half now because we have to make 2 regions of equal area, which means we're probably going to be a little bit beyond the 1, about here perhaps, because that one goes up higher. You would not draw it straight down at 1, no. Yeah, first off, that wouldn't make any sense with the answer. Wouldn't it just be x equals 1? No, obviously not. Okay, so what do we do then? We know that we want the area of this to be 4/3. And while we know that this value here is a, that doesn't mean that the height is a. What is the height? It's the y coordinate when x is a on this one right here. One of the small notebook concepts we talked about is that for any x, y, the absolute value of x, don't just think of it as a place to put a dot, it's the distance from the y-axis. And the absolute value of y equals distance from x-axis. Okay, so always consider that as one of the ways to interpret the ordered pair. This is a small notebook concept. You might want to write it down. So now, let's go ahead and go here. So we have here, how are we going to get it? You're going to plug a in here, and it's a over 3 plus 1. So it's a over 3 plus 1. And what we're going to do is the same thing we did before, the average of the bases times the height. So the average of my bases is 1 plus a over 3 plus 1 divided by 2. That is the average of my bases. What is my height? My height is a. A is the distance from the y-axis because it's an x-coordinate, and all x-coordinates absolute value is a distance from the y-axis as we just discussed. So I'm going to put that here. That is the area of your trapezoid. And so the next thing that you're going to do is set that equal to 4 over 3. Now for me, we're going to multiply by 2 to get rid of it. So I'm going to go over here and we're going to get rid of this and put 8 instead. It's like we're back and forth multiplying, dividing, and multiplying and dividing by 2 in this problem. All right, so now we're going to have 2 times a is 2a, and a times a over 3 is a squared over 3 plus this equals 8 thirds. Now I'm going to go ahead and multiply by 3. It's going to go away here and here, but make this 6a. And so now we're going to have a squared plus 6a minus 8 equals 0. And you might be looking at this going, I wonder if it factors. No. No, not going to happen, but it looks kind of like ones that factor because you're thinking the 4 and the 2, but they're opposite signs. So get rid of that thought. By the way, the a can be written as this, where s and t, the a can be written, you kind of don't read that really. You just need to find what a is. The a can be written is kind of code for stop reading, because we don't care how they're going to write it, other than observe there's a square root somewhere in our answer. But besides that, don't think about the rest of this yet. You stop reading because you need to find a before you care exactly what this says. Okay? So we have to find a way to get a. We've done that. We've got a way right here. Let's erase that toxic looking 8 because I don't like how it looks. Now what we do? We're going to do quadratic formula. Negative b is negative 6. Is it plus or minus? No, it's only plus. If it was minus, you get a negative. So we get plus the square root of 36 minus 4ac. The 1 here we don't care. That's negative 8. 4 times 8 is 32. I'm going to make that 68, which is 4 times 17, which is 2 rad 17. We get negative 6 plus 2 rad 17 all over 2. Divide and you get negative 3 plus rad 17. Whoops, let's make that look a little bit nicer instead of a D. Should be negative 3 plus rad 17. So these parts right here, your calculation, you do pick up speed when you're good with numbers under 100. I highly recommend you get to a point where you can instantly prime factor any number under 100. Like literally 0.2 seconds, you can say exactly what it is. It's great because when you're reading slow and being careful, that's where you can pick up your speed at. So now look at this and we compare it to this. As root 17 minus 3, s and t are positive integers. 17 plus 3, gonna get us 20. And that's C. I wonder how many C's in a row we're about to get. We'll find out shortly. Let's get to problem 7. Francis in problem 7. Let's do it. 2025 10B, problem 7. Francis stands 15 meters directly south of a locked gate in a fence that runs east-west. Immediately behind the fence is a box of chocolates located X meters east of the locked gate. Let's draw what we have so far. So we have here, we'll call this L. We'll go over here and call this C. That's the chocolates. The chocolates are basically right behind the fence here, but I'm putting a dot where it would be located. And Francis is over here about 15 units, exactly 15 units south, directly south. Okay, so then from here, an unlocked gate lies 9 meters east of the box. So we'll continue over here and you'll say 9 and you'll go over here and this will be unlocked gate east. And another unlocked gate lies 8 meters west of the locked gate. So you'll go here, that will be west, and W and 8. Francis can reach the box. It's interesting too because I made my little chocolate angle joke, the angle being CA, and then you get cacao like chocolate. And now we have chocolate later, and this is very chocolatey test at this point. Okay, he can reach the box by walking toward an unlocked gate, passing through it, and walking toward the box. It happens that the total distance Francis would travel would be the same via either unlocked gate. What is the value of x? I mean, the first thing is you're going to have to draw a straight line. This is an unlocked gate, and this is an unlocked gate. And you might say, well, 8, 15, 17, and you might have hope that maybe this is also a Pythagorean triple. But looking at the answers, I think maybe that might not be exactly a best call, since x is clearly not going to be an integer. You'd have to multiply it by at least 7 to be able to get a potential Pythagorean triple. I probably wouldn't want to do that. So instead, what will we do? We're going to represent this distance as the square root of 15 squared plus x plus 9 squared. And so now we're just going to make an equation. We're going to say 17 plus 8 plus x. So if he goes this way and then over that way, it'll take him that long. And this one's going to be the square root of 15 squared plus x plus 9 squared. And you might say, well, why don't you square it? And I say that you never calculate until you have to. And so we're going to leave it just like that for now. And we're also going to add x plus 9 on this side. At this point, I'm going to cancel some things out. So in other words, he goes here and then 9, actually not x plus 9, just plus 9. Woo, okay. Got to put that 9 back. Plus 9. Okay, are we good now? That plus 9 to get there. Yes, good. Okay, so what's going to happen next? We have 25. We're going to subtract 9 off of that. So we get x plus 16 is equal to, and I'm not even going to write it. I'm actually going to go ahead and just simply square. Okay, so what we do is we anticipate writing this here, and then we square instead. So we get x squared plus 32x plus 16 squared. And this is going to equal, why don't you write 256? Again, reasons have been previously stated. Plus x plus 9 squared. Okay, so we're going to have an x squared here. It's going to cancel this x squared, just like that. We're also going to have an 18x, and I will write 81 here. We're going to subtract 18x over here and get 14x. We're going to move 16 squared over, so we're going to get 15 squared minus 16 squared plus 81. Now, one of the things you learn in my small notebook class or in other classes that I teach is that the difference in consecutive squares is the sum of their bases. So this must be negative 31. And negative 31 plus 81 is going to be 50. So negative 31 plus, why negative? Because the 16 squared is bigger. Now we're going to get that x is equal to 25 over 7, canceling the 2 in our head. This is 21 and 4, so 3 and 4 sevenths. And we got C yet again. I wonder if we'll get any more. Let's see. That's actually not a pun, but that's kind of funny. All right, so now we'll do 2025 10B problem 8, the first in your rapid fire set for 12B, problem 6. Emmy says to Max, I ordered 36 Math Club sweatshirts today. Max asks, how much did each shirt cost? Emmy responds, I'll give you a hint. The total cost was this right here, but there's a decimal point here if you can't see it, where A and B are digits and A does not equal 0. Very clever, Emmy. So after a pause, Max says, that was a good price. Oh, okay, so Max is obviously somebody who knows number theory here. The question is, do you? So what is A plus B? The idea needs to be this. If you're looking for each shirt costs the same amount, obviously, right? So you're going to divide 36 into this number and it must go in equally. Do we care about the decimal point? Not really. We don't care. Just consider it as cents. It's all cents. Does that make sense? Okay. Now what we're going to do is this. Your digit sum is going to have to be a multiple of 9. And the last two digits are going to have to be a multiple of 4. So that's kind of the rules we're going with here. How do you know to pick 9 and 4? You pick two numbers or integers that are relatively prime whose product makes the larger number. So for example, if I wanted to know if 18, the divisors would be 9 and 2. If I wanted 24, it would be 8 and 3. So you can't have a common factor in either of the two numbers, and they must multiply to the larger number. 12 would be 4 and 3. Okay? So 36. So here we go. We've got 2 A's and 3 B's. If you got that in school, you'd probably get in trouble, but luckily here we don't have to worry about that. So this needs to be equal to a multiple of 9. We also need BA to be a multiple of 4. This is just kind of like, here's how I did it. This is a multiple of 9, and this is a multiple of 3. The only way this is going to be a multiple of 9, which is a multiple of 3, is if I add a multiple of 3 to another multiple of 3. It doesn't matter what B is. This is a multiple of 3. If this is not a multiple of 3, you would never get a multiple of 9 because 9 is a multiple of 3. Okay? This is a theorem that you learn or a property that you learn in Intro to Number Theory. Again, new class starting the first week of December. If you'd like to try that class out, there's 6 spots left. So from here, we say what? This has to be 0, which is not allowed, 3, 6, or 9. So if I try 3, can A be 3? No, because it can't end in 3 and be a multiple of 4. So it's going to have to be 6 because it can't be 9 as well. So this is going to have to be 2 times 6, which is 12. So I've got 12 plus 3b. A multiple of 9. Why don't I make b interesting? 2. Why don't I make b 2? We'll try that out. So if I put 2 in here, I'll get 12 plus 6. Let's see if 2 would work. But the problem with 2 is it doesn't work with the BA. We can't have 26. So what else could we do? From 12 to 27, 25 is not going to make it there. How about to 36? B could be 8 now. The problem is 86 doesn't work either. A being 6, 2A plus 3B. Oh, did we really can't get 6 here? Okay, so we got 12. We can't add 6. We could not add 9. Could we add 12? That wouldn't be a multiple of 9. So we are going to need, let's see, 46 won't work. And then 56 could work. What about 56? Oh, that'll work. Yes. Oh, why did I think it wouldn't work? I was thinking 25. So yeah, 25. This will be 15. So yeah, here we got 2 times 6 plus 3 times 5. There we go, great. 12 and 15 is 27. And these things happen when you're live solving too. If you make little errors like that, it's normal. Don't be too hard on yourself. Your brain doesn't always work in perfect, action and thought processes. So here we go. Then this now makes this 56, which is a multiple of 4. It's 4 times 14. So at this point, we have the values, and A plus B will be 6 plus 5. It will be C, 11. Let's get to the next one. So now, 2025 10B problem 9. How many ordered triples of integers x, y, z satisfy the following system of inequalities? What's interesting is this is the second themed kind of problem. that has appeared on this year's contest. First you had the Pascals earlier, but you now also, if you had done the AMC 12 problems, which I recommended all of my AMC 10 students to do, especially the ones that could play a crossover, there was a question number 18, which had something like x, y is less than z, something like that, and there were 3 of those, and it also had what I would call a symmetric layout. And that's what this one has. What do we mean, what do I mean at least by symmetric, is that you have a negative x, a negative y, and a negative z. In all 3 of these, the other 2 are positive. And the other side is always positive 2 and it's less than or equal to 2. And in this equation, they're all playing or inequality. They're playing the exact same role of a negative version of themselves, and they are less than or equal to negative 2. In other words, if we find a solution, say we found, it doesn't work, but let's say we found 1, 3, 2, you would have 6 arrangements to this solution simply because it could work for all of them because of the symmetry. Okay, so if you were in my class that reviewed that, you might remember that problem and going over it. And hopefully it gave you an edge on this problem here. Because this one could have been a time drain for people. It might have taken you a little bit to convince yourself of the truth. I didn't do this problem in the 6 through 10 right after the 1 through 5. I skipped to 11, came back and got it in the final 25 minutes. And they actually weren't that bad this year, or maybe it's because I also wasn't as stressed. I was able to get through the 6 through 10 a lot quicker than I did on the A test. So what are some things that we can do from the start? We have to create some kind of analysis. What I would do is probably add, because I like the negative 2 and the 2 adding, and if I add 2 things that are lesser, it will stay lesser. So if I add these 2 things right here straight up, I get my y's to cancel, my z's to cancel, and I'm going to get negative 2x less than or equal to 0. Understand that because of the symmetric effect, I can also make negative 2y less than or equal to 0 and negative 2z. They're all going to work this way. Now, I'll multiply by negative 2, or divide rather by negative 2, and I will get x is greater than or equal to 0, which means x, y, and z are all greater than or equal to 0. And this is really kind of interesting because in the other one, it was non-negative integers and x, y, and z could be 0, but by doing inspection and thinking, you realize they actually could not be. Is that going to happen again? Let's find out. So from here, we know that they're all greater than 0. What else might we do? I kind of want to add 2 of these equations now, and if I add them, these will cancel, and these will not, and I'm just going to get 2z is less than or equal to 4. So again, you're going to get z is less than or equal to 2. The other thing that you might want to do is multiply this top one by negative 1. I know that x plus y plus z must be greater than or equal to 2 as well. So we have x greater than or equal to 0. But in fact, we actually can put them in a compound inequality. We can say that x, y, and z are all greater than or equal to 0, but less than or equal to 2. Again, if I add these 2 equations, it will say 2z less than or equal to 4, and then you can divide. How do you add inequalities since they're both less than? If I add the 2 lessers, it's a property of order. It will stay lesser afterward. So now what do we do? Well, let's do some trial and error. That's why the 3 wouldn't work in my imagined ordered pair. Could I have, let's say I'm going to have 0 in one of them. Could I have 2, 2, and 0 like this? The answer is no, because if we made 0 the negative wherever it's at, in this case this equation, then I would have 4 minus 0 and it's not less than or equal to 2, so this won't be allowed. If 0 is involved then, these are the little rules that you make up, right? So this is the most important skill to have on the test, is the ability to adapt. You are coming up with, this is a open field question. You don't come in with an exact science about how you go about things. Instead, you determine the rules as you go, and then you prove them to yourself. So you're forming a hypothesis, a suspicion, you test it, you then give yourself evidence in supporting of your theory or support of your theory, and you either prove or disprove what you hypothesize to yourself. You don't come in with a small notebook concept for something like this problem other than maybe properties of order, but the actual thinking is all going to be done live during the test. And there isn't something that you could do before to kind of just bull rush the whole problem, typically speaking. So in that case, we're going to make a claim that if 0 is involved, these two cannot be larger than 2. For the simple case that when I subtract 0, these two have to add to no more than 2. So let's see what we get then. So we're going to have, could we have 1, 1, 0? I think that could work. And all the others won't matter. They'll all be less than or equal to 2. And over here, it's less than or equal to negative 2. Oh, and we get, or same thing, we get greater than or equal. This is a little bit easier to think about. So the sum of the 3 is greater than or equal to 2. So this would be okay. So this is going to be a case, and you're going to get 3 ways. Why 3? All of the symmetric arrangements. So now, what if I had, could I have one with 2 zeros? And the answer is no, because those sums would not be greater than or equal to 2. So I can't have that. So if I have 1, 0, could I have a 2, a 1, and a 0? No, we already said the other two can only add to 2. And we proved it to ourselves by imagining subtracting 0. Remind yourself of the things that you've concluded, and why you concluded them helps you feel more secure in your answer as you go. Because as you're going to see at the end, you might not feel secure, and you want to have as much security as you can before you move on. So from here, we have that one. So I can't have 1, 2, and 0. I can't have 2, 2, and 0. I can't have 2 zeros and a 1 because we don't get greater than or equal to 2. So now, what about something like 2, 2, and 2? Is that going to be okay? Sure, it's going to be okay because I add them, they're definitely greater than 2. If I make 2 positives and 1 negative 2, it's equal to 2, so it's less than or equal to 2. It falls in there. It's going to work. Could I also have 1, 1, 1? For the same reason you could. If I add any 2 1s and subtract 1, I'm less than or equal to 2. If I add the 3 1s, I'm greater than or equal to 2. So this is going to give you 2 ways. Now, what's left? We've got 3 ways and 2 ways. What about 2, 2, and 1? Will this work? No, because you have to have your 2 larger minus 1 be less than or equal to 2. Notice that as we go on, we give ourselves more clear and clear direction about what we are allowed to do and not allowed to do. We're making up the rules as we go. This is what the test is famous for. It's these problems like this where you don't come in with the preset of rules other than knowledge about inequalities. You have to construct and create the rules as you go. Another one like this was the special fractions a over b that added to 15, and you wanted to know how many integers could be made by adding any two, not necessarily distinct. That was the same kind of reasoning as this problem. So I call it open field or open-ended kind of reasoning. So from here, you have 2, 2, and 1 doesn't work because 4 minus 1 doesn't stay under 2. Then in that case, could I go 2, 1, 1? That will work because 3 minus 1 will get us under the 2. The sum is more than 2. So how many arrangements will this have? This will have 3 ways. Now what else could we have? Could we have 2, can't have 2 2s and a 1. We can't have a 2 and 2 1s, or we can have a 2 and 2 1s. What am I forgetting here? Because we're only at 5, 8. Oh, we're at 8 right now. Is that really where it ends? I think there's one more. My brain said there was one more when I solved earlier today, but maybe there wasn't. I'm misremembering. 1, 1, 0, 3. This has 2. That has 3. Maybe it is this. Let me check what I gave myself for an answer on this. Can't find the paper right now. Let's see what else we could come up with. Any other mixtures of 2s and 1s? Could we have 2 1s and a 0. We can't have a 2 and, why can't we have a 2 and 2 zeros? A 2 and 2 zeros. Could we have that? It does sum to more than 2. Why did I think we couldn't have this earlier though? We thought we could not. It doesn't matter where the 2 is. It would never get more than, you can do this. Okay, so then this is going to have 3 ways also, 3 ways to arrange the 2. Well then what about a 1 with 2 zeros? 1 with 2 zeros would not get you to at least a sum of 2, so it breaks that rule. So 1 with 2 zeros is a no, 2 with 2 zeros is right. Gonna work. Make sure, one more time. If I add 2 zeros and subtract 2, we're good. If I had a positive 2, we're good. If I put it up here, we're good. It obeys all the things. I think it's good. So we've got 5, 8, 11, and we get one more time answer choice C. There was a lot of C's in a row. I believe 5 through 9 all came out to be C. So if you just went on a random C guessing spree, you would have done very well right there. Let's go on to problem number 10. The last problem of this rapid fire set, 2025 10b problem 10. Let f of n equal n cubed minus 5n squared plus 2n plus 8, and let g of n equal that. What is the sum of all integer values of n for which the quotient f of n over g of n is also an integer? So this is going to be rational root theorem. This is all covered in second semester Algebra 2. It's also covered in pre-cal. So rational root theorem, there are speed shortcuts to these kinds of processes though. So one of you I tutored recently and we did synthetic division, but we talked about with synthetic you always first check if 1 or negative 1 works using the factor theorem, the remainder theorem. So those two theorems combined basically. So if I plugged in 1 and got 0, then x minus 1 or n minus 1 would be a divisor of this polynomial. But if I plug in 1 and don't get 0, then it's not a divisor. This is the third theme because we use this on the A test. We use the factor and remainder theorem on that test as well. I want to say it was around problem 9. This is the third theme between the two tests. Amazing. Okay, so we plug in 1. It obviously doesn't give 0. Negative 5 is the only negative. What if we plugged in negative 1? If you plug in negative 1, all of your odd powers will change sign. So I would get negative 1, negative 2, and negative 5. Negative 1 minus 5 minus 2. That's going to equal 0. And because it does, you know that x plus 1 or n plus 1 is a factor of this. So we're going to put negative 1 is what we plugged in. We're going to put negative 1 in the box. This is the C value when you do f of n over n minus c. That's what it is. That value, which c is negative 1, which means the factor is n plus 1. Okay? N plus 1. So be very careful with that here. So now we're going to just copy the coefficients down. 1, negative 5, 2, and 8. 1, negative 5, 2, and 8. So again, one more time, if you do f of x over x minus c, and this gives you your q of x plus your remainder over x minus c. In fact, your remainder will just be r because your divisor is linear. And so in this case, if this happens, then f of c is equal to your remainder. And if your remainder is 0, it means it divided in evenly. There was no remainder, which means this becomes a factor of that. Another way to think about that is if you put c in the box and you get 0 over here, or whatever you get over here, that's the value of the remainder, and it's equal to the function evaluated for c. So we want our remainder to be 0, and it is. When we got 0 here, we know that we're in for good luck. Not good luck, but we know what we're doing is going to be an effective process. So you drop the 1, multiply by -1, you get -6, you get +6, you get 8, you get -8, and you get 0, exactly as desired. What's left is x squared minus 6x plus 8. That's going to be x minus 4, x minus 2. So we're going to have x plus 1, x minus 4, x minus 2. If you can't see what this is, it's 1x squared minus 6x plus 8, and you're setting it equal to 0. I'm going to just use it like an equation right now. And so when you do that, the two things that multiply to 8 are -4 and -2, and they add to -6. I always use things I've already written to do things in problem solving. So now we're going to do the same thing for g. We look at the -6, the positives are too big. What if I plug in -1? It'll change these to -1 and -5. Combine with that, takes that out. It's going to work again for g. So you've got -1 in the box, 1 minus 6, 5, and 12. You drop the 1, you get -1, you get -7, you get 7, you get 12, you get -12, you get 0. And we have the same situation as here, but with a 12, which makes it 4 and 3. So we're going to have x plus 1, we're going to have x minus 4, we're going to have x minus 3. How do I know they're both negative? Because both negative multiplies to +12 and will add to -7. Just like if you multiplied out here, x squared, and then you get minus 2x minus 4x, it's that -2 and -4 that you're adding to get this. So from this point, that's f of n over g of n. I'm going to note right now, it's not n, I want to use x, okay? It's going to be easier to use x than n. You remember x better. X cannot equal -1, 4, or 3. Keep that in mind. Meanwhile, we're going to cancel here, here, and here, and here, and so you get x minus 2 over x minus 3. But x cannot equal 4 or 3. The thing is, this is 1 less than that. How are you going to get integers with a number that is 1 less in the denominator? So if I write some samples down, is 5/6? No, actually it's 6/5. 6/5. The larger one is above. So if you write 6/5 not an integer, 5/4 not an integer, how long is this going to go? How about if we get down to 3 over 2? No. 2 over 1? Good. How about 1 over 0, undefined, -1, no, 0 over -1, and then you're going to have -1 over -2, and so on. So let's look at these values really quick. Let's write that one again. So 0 over -1. The thing is, in order to get 2 over 1, what does x have to equal? Unfortunately, x has to equal 4. Well, we actually can be careful. I don't think it can, because it is the full g of n. And in the full g of n, if you let this be 4, it's going to give you 0. You can even just double check. 64 minus 6 times 16 plus 20 plus 12. That's -96, and 32 and 64 is +96. That's not going to be an integer. So this would have been good, but it doesn't work because you use a value here. I bet we find a trap answer for that, by the way. This doesn't work undefined, but 0 if I let x equal 2. X equals 2 will give me 0 over -1. Nothing else is going to work again because it's always going to have a difference of 1 in the two numbers. We know this is the only case that works, which is going to make the answer A. If we had included the 4, we would have gotten 6. And if we had continued our guessing spree of all C, because 5, 6, 7, 8, and 9 all being C, we would have gotten something very explosive. C4. Let's get to the next problem.